Well, welcome back to the third video in our current series on More SQL. In the last couple of videos, we were exploring some of the nested queries that we can use, where one query is being used as part of the where statement for the other query. Now we're going to examine some more options. In this video, why don't we use the word explicit? Explicit as our mystery word, because we're going to be talking about some explicit values to use in these queries in this very first one. We have seen several queries with a nested query in the where clause. It's also possible to use an explicit set of values in the where clause rather than a nested query. Such a set is enclosed in parentheses in SQL and is shown in the next example. Here you see query 17. Select distinct ESSN from work zone where Pno in, and there you see the parentheses with the literal values of the set. Note that the literal values that we see here are not enclosed in quotes, which tells you that the data type for these is some form of numeric data type, because had they been a string, they would have been enclosed in single quotes. But that's another story. In SQL, it is possible to rename any attribute that appears in the result of a query by adding the qualifier as by the desired new name. Take a look at query Q8A. Select e.lname as employee name. We have two aliases here. The first alias is this E, which represents the employee table as we see described right here, employee as E. The second alias is this employee underscore name, which is an alias for the attribute name lname. What this does is make your output from your queries a little bit more understandable, perhaps, by using column headings that really describe the attribute a little bit better than perhaps the name that it was assigned at database development time. For example, in this case, we have e.lname and we have s.lname. And so this query would pull these two attributes up side by side with a column heading that says e.lname and s.lname. You have to admit that column heading that said employee underscore name and supervisor underscore name is a little bit easier to understand. So, as we see, the alias can be used for both the relation name and the attribute name in both the select clauses and the from clauses. The concept of the joined table or joined relation was incorporated into SQL to permit users to specify a table resulting from a join operation in the from clause query. This construct may be easier to comprehend than mixing all the select and join criteria in the where clause. For example, take a look at this query. This is a traditional query. Select first name, lname, and attribute from employee, department, the two tables we're going to use, and the where statement selects the criteria that we want where all the employees are in the research department, and it also accomplishes the join operation of joining these two tables together by the common foreign key primary key values, dnumber equal dno. Now it might be easier to separate that process right there so that the where clause just states the criteria that we're looking for and the join is handled up here with the from. Let's take a look at another example. Select, same query, select first name, last name, and address from, and notice in parentheses here, we identify the two tables that we're going to retrieve data from and join them together in the same process. From employee join department on dno equal dnumber. And then our where clause is limited to simply the criteria that we really want to use for this query. That is, that the department name is equal to research. So perhaps this version of the query might be easier to understand than perhaps this version. The concept of a joined table also allows the user to specify different types of join, such as natural join and various types of outer join. In a natural join on two relations, no join condition is specified. An implied or implicit equijoin condition for each pair of attributes with the same name from the two relations is created. Each such pair of attributes is included only once in the resulting relation. If the names of the joined attributes are not the same in the base relation, it is possible to rename the attributes so that they match, and then to apply natural join. Let's take a look at this query. Select fname, lname, and address. From employee natural join, open paren, department. Now, natural join, if both of these tables use the same name for the attribute department number, a natural join would be employee natural join department. But in this example, the department table actually uses an attribute name called dnumber for its department number, whereas in the employee table, the designer is using dno to represent the department number that the employee is a member of. So we have two different names for the same value. In order to use a natural join, we're going to have to rename one of them. So in this case, they're creating an alias for the department table called DEPT, in which it does specify attribute names for the new table, including dno, which is in fact a rename of the dnumber attribute in the department table. So essentially, by creating this alias, DEPT, we are converting dnumber attribute name to dno, which would be the same as the attribute in the employee table, making this the equivalent of entering employee natural join department. The default type of join in a join table is called an inner join, where the tuple is included in the result only if a matching tuple exists in the other relation. For example, in query QAA that we looked at earlier, only employees who had a supervisor are included in the result. An employee tuple with a null value for super_SSN is excluded. If the user requires that all employees be included, an outer join must be used explicitly. In SQL, this is handled by explicitly specifying the outer join in a joined table, as illustrated in Q8b. Select the attributes in the various aliases from open paren, employee as E, left outer join, employee as S on E.super_SSN equal S.SSN, close paren. Employee as E, left outer join. There are your key phrases. Left outer join. That left outer join means that every tuple in the left table must appear in the result. So if there is no value, if there is no matching tuple on the left side, then it's padded with a null value. In SQL, the options available for specifying joined tables include inner join, which is the same as join, where only pairs of tuples that match the join condition are retrieved. Left outer join, as we see in this case, specifies that every tuple on the left table must appear in the result. If it does not have a matching tuple, it is padded with null values for the attributes on the right side. Right outer join means that every tuple on the right side must appear in the result. If it does not have a matching tuple, it is padded with null values for the attributes of the left table. And full outer join, which does all the above. In the latter three options, the word outer may be omitted. If the join attributes have the same name, one can also specify the join variation of outer joins by using the keyword natural before the operation. For example, natural left outer join. The keyword cross join is used to specify the Cartesian product operation, although this should be used only with utmost care because it generates all possible tuple combinations. Take a moment to use your search engine to find Cartesian product in order to answer a question that will appear in your Check My Knowledge assignment for this video. We already have the mystery word, so submit that. Do your Google search or your whatever search engine you prefer to look up Cartesian product, and then go out and take the Check Your Knowledge assignment for this lecture. And when you're done, we will move on to video number 4 in the series on More SQL.